In the previous video, we imported Klines using the basic request. But Binance limits each request. So what happens if you need 2,500, 3,000, or 10,000 candles? Today I'll show you how to import unlimited historical candles safely, without duplicates, and without breaking the API weight limits. At first, we import the necessary modules. And then, the model from the previous video. To define the function, we need to go to Binance documentation. So we can obtain the endpoint, method, weight. Mandatory and optional parameters. And a respond example. At the start of the function, there's all information from the Binance API to make the request possible. Most beginners think increasing the limit is enough. Max candles per request and sleep time are not parameters from the API, but they are crucial to make this function work. The idea of this function is simple. We fetch candles in batches. We move backwards in time using endTime. We avoid duplicates. We stitch everything together in chronological order. We create a list of batches. endTime and previous first open time is what will allow concatenate the candles together without duplicates. Let's start looping until the number of requested candles is reached. The loop ends when the number of candles from the batches reaches the total candles. We have to store the remaining number of candles and then the number of candles that are missing. Now, the function from the previous video is used to import the candles. If the data frame with candles is empty, the loop must stop. And if data is the same from before, the loop must also stop. After this, previous open time has to be the current open time to start a new loop with more recent candles. When paginating with endTime, Binance returns the boundary candle again. That means the last candle of the previous batch appears again in the next response. If we don't remove it, we create overlapping data. So here, with this, we remove the last row to prevent duplicate candles. All batches now has to receive the new candles that we imported. Then we have to check if the number of candles was reached by comparing the size of all batches together with the number of needed candles. endTime must be updated to push the eldest candles. Binance uses a request wait system, and each API call consumes weight depending on how many candles we request. If we send requests too fast, we risk hitting the rate limit, which can result in temporary bans or errors. This small delay helps us stay within safe limits, makes the data import more stable. With this, we have ended the loop part. All batches now can go into a DataFrame. To avoid a bigger number of candles that was imported, the DataFrame can be trimmed on the index. Each column from the data frame is the key from the documentation response. All values are imported as strings, so they must be converted to numerical values, floats, and int. To be more readable, we can convert timestamp into dates. We don't need the ignore column, so let's delete it. This data frame is what the function is going to return. Time, for an example, by using Bitcoin dollar tether in 5 minutes. The number of requested candles will be 2,500, which is greater than the API limit. Let's call the function and store its result into a new variable. And then print it to check the result. There's the result. Let's print all data from the data frame. There's the result. As you can see, each column is a key from the response. We can try a new example now, and with 30,000 candles. The response will be slower, essentially because of the multiple sleeps. Here we have all printed. Let's resume the print. Perfect. Everything is as expected. Now we have a clean and scalable way to import unlimited historical data from Binance. This is the foundation of any serious trading system. Without clean data, indicators are wrong. Without consistent data, backtests are meaningless. If you're building automated systems or planning to, this is where things start getting interesting.